Hi guys, welcome to Programming Knowledge Hub. My name is Vishal. This is the fourth lecture of the tutorial series C# tutorials from scratch. In this lecture, we are going to see what are the different types of data types in C#. In previous lecture, we saw the following topics: what is a variable, how we can declare and initialize the variable, how the memory is allocated to variable, etc. And one practical application. If you haven't seen my previous lecture, I strongly recommend you to watch the previous lecture of this tutorial series. In this tutorial, in this lecture, we'll see what is a data type. Okay, then what are the types of the data types in C Sharp, how we can convert one data type to another either implicitly or explicitly, and what are the difference between signed and unsigned data types, what are the minimum and maximum values that can be assigned to data type, and the size of the data type. So what is a data type? Let's see. A data type is the type of the variable. Okay, a data type decides what range of values that can be assigned to the variable. For example, let's say we want to declare a variable named age of data type int and assign a value 12 to it. Okay, so this the data type int decides what range of values we can assign to the variable age. As you know, the C Sharp is a strongly typed programming language, which means each variable must have the data type associated with it. So this is just example which I mentioned explain right now, that we declare that declare the variable age of the data int and assign the value 12 to it. What are the different types of data types? So first understand, the object is the base type for all other data types. Okay, all other data types are derived from the object data type only. So for a categorization purpose, there are basically two types of data types. The first is value type and the reference type. Then what is the difference between these types of data type? The only difference is that the way these variables of these data types that are going to get the memory, that are going to allocate the memory by the compiler. Okay, there is only this difference. In case of value type data type, the values are directly stored in the variable. Okay, so let's say we declare, let's take the previous example. We declare the variable age of data type int and assign the value 12 to it. Okay, so the compiler creates a block in the memory and stores the value directly into that block. Okay, the block compiler assigns the name of the variable to that block, let's say age, and directly stores the value in that block. Okay, but what happens in case of reference types? So for the reference type data types, instead of directly storing value, the reference or address of that value is stored in the variable. Okay, we'll see what does that mean. So I'll just take an example. Let's switch back to the Visual Studio. I just show you practically. Let's say declare a variable int age equals 12. See, we declare a variable named age of data type int and 12. So what happens behind the scenes? So the compiler creates a block in the memory named age, okay, and which is of data type int, and directly stores a value inside that block. Let's say we create another variable of type float amount equals 12.5. Okay, so oh sorry, we have to assign this f to it. Okay, so similarly, compiler creates a block in the memory named amount, which is of type float data type, and assigns the value 12.5 to it. So this f is a suffix which we must assign to the flow value of float data type. So now let's see what exactly is the value type and the reference type data type. So all the predefined data types in C# are a value type data type. For example, integer, uint, byte, sbyte, float, that we just see right now. All these data types are value type data types. Also, some user defined data types like enum, struct, value tuple are also value type data types in C#. What is the difference between these types of data types? In case of value type data types, it is easy to access the value because the value is directly stored in that block of memory. Okay, so we can directly retrieve that value. But in case of reference type data type, for example, take the example of classes, interfaces, strings, and arrays. Instead of directly storing value into that block, the compiler stores the address of that value, the reference of that value. So it is a little bit difficult to retrieve that value. There is a we have to follow another. We have to write a few lines of code for that. But in case of value type data, we can directly retrieve value from that block. So if you want to know programmatically how we can find that if the variable is value type or reference type, so as you can also remember, all these predefined data types in the C# are value types. But still, if you want to find out programmatically, then we have the method get type method. So let's say I want to print the I want to say find out whether the int is a value type or reference type. So I have one method. Let's say the int data type is, let's say, plus age, the integer variable, dot. See, here we have a method called get type. So what does this method do? This method gets the system.type of the current instance. Okay, let's use this method, call this method, and press Ctrl S to save the application. Press Ctrl F5. Let's see what it prints on the console. See, it prints the system.in32. So what is this? System.in32. This doesn't say it's a value type. So don't worry. System.in32 is nothing but the .NET type name for this integer. In simple cases, system.in32 is a .NET type name and integer is an alias name. Okay, there's basically no difference between these two types. We can either declare this system.in32 like this. Okay, and see, there is no difference. Okay, so it is also correct, the integer is also correct, and system.in32 is also correct. But instead of writing these two words, which is a which is more difficult, we can say is a better than just normally writing int. Okay, so integer is an alias name given to the system.int32 data type. Okay, similarly, if you want to get the alias, if you want to get the .NET type name for the float, you can simply write the same statement. The float data type is, so let's change it here. The float .NET class name for float type is, let's say, what is the variable amount dot get type. So you will receive, it will print the .NET type name for this float data type. See, it's a system.single. Okay, you can experiment with the another data type like double, the byte, s byte, uint, long, etc. So we were actually here to see how we can understand how to know if the int is a value type or reference type. So to know that, just press the dot here and say the property base type. Okay, similarly to the here. So what does this base type attribute do? It gets the type from which the current system.type directly inherits. Okay, so it gets the base type from which the system dot, let's say, type was in32, that was inherited from which base type. Okay, so let's run this application. Let's see what it prints in the console. See, it has printed system.value type. The float is also system.value type. Okay, so using the base type property and get type method, you can find out what is the type of the variable we have declared here. Okay, you can experiment with the other data types like uint, s byte, byte. You can experiment with those data types and you can get the types as a system.value type or system.reference, whether it is a value type or a reference type variable. Okay, so there is another concept of conversion between data types. The data type can be converted into another data type, for example, byte to short, int to long, ushort, etc. Then basically there are two types of conversion. There are two methods in which we can convert one data type to another data type. Either it is implicit conversion or explicit conversion. The implicit conversion is taken care by the compiler itself. The developer don't have to write extra code for the conversion. Okay, so the C# automatically converts one data type to another implicitly, followed by certain conditions, certain rules. Okay, so what are the rules for the implicit conversion? See, the implicit conversion happens when the destination data type is larger than the source data type and both the data types must be compatible. Let's see what does this mean practically. See, so first delete this code. Okay, so let's understand here that I want to convert the byte type variable. Say let's say I declare a variable b of data type byte and assign a value, let's say 50, only 50. Okay, so I want to convert this to another data type, let's say integer. So to convert it into integer data type, I declare the data type, I declare the variable of data type in, let's say I, and equals b. So using the equals operator, we assign the value of b to the value b to the I, the variable of integer data type. Okay, so this is called the implicit conversion. See, we did not write any extra code to convert the b to I. We just use the assignment of operator over here. So compiler takes care of this conversion. So compiler sees that the destination data type here, the destination data type is int. It is larger than the byte data type. What do you mean by larger? The larger means we can store large amount of values. The range of value is larger than the byte data type. So compiler automatically converts it. Let's say print it on the console. So the value of I is print is here I. Okay, so it will print the 50 on the console. Let's see. See, it has printed 50. Okay, no difference. But this is the first rule that the destination data type must be larger than the source data type. But there is another second rule that the both data types must be compatible. What does the compatible means? Let's say I have a string variable and assign the value John to it. Okay, fine. And I want to convert this to integer variable. Okay, let's say integer j equals str. Let's see what happens here. The compiler has given us error. Cannot implicitly convert type string to int. Okay, you cannot convert the variable of string data type to the variable of integer data type. Okay, because these data types are not compatible. Okay, so this is the implicit conversion. Now let's understand what is an explicit conversion. Okay, so actually when the data type cannot be converted implicitly, the compiler wants you to convert the data type explicitly by applying cast. So what does this mean? What is a cast? Let's say cast means we explicitly tells the compiler that this is the destination data type to which I want to convert the source data type. Okay, but in this case there is a chance of data loss. The same means if you have some value which is preserved in the source data type and while converting explicitly to another data type, there may be some, you can lose some value, you can lose certain value. Let's see practically, not worry about it. Okay, here the same rule applies to the explicit data type, that the data types must be compatible, and for example the trying to convert from string to int will throw the compile time error. Let's understand the explicit conversion now. Let's see, I have integer variable int I equals 100. Okay, and I want to convert it to the byte. Okay, I have to convert it to the byte. Okay, so the data type is integer is bigger than byte. Let's say how we can convert it. Byte b equals I. See, it has given an error, cannot implicitly convert type integer to the byte. Okay, and explicit conversion exists. So to convert explicitly, just apply the cas, and it is like byte a byte. See, we specified in the parenthesis the destination data type to which we have to convert the source, that means integer data type. So it has converted the value. Let's print it on the console to see it works fine. The byte, the value, the value of b is b. Okay, let's run it by pressing Ctrl F5. See, the value of b is 100. Okay, so here this is called as explicit conversion. Okay, then I also told you that you can lose some certain value if you try to convert it explicitly. When if you try to force it by applying a cast, you can lose certain value. Let's take an example where we have float f equals 12.5 f. Okay, it's a float variable and you want to convert it to the integer variable, int I equals f. Okay, so you're gonna convert implicitly. You have to apply the cast, let's say integer here, and the cast, and print. Let's say what happens. Press Ctrl F5 to run the application. Sorry, it's taking too much time. See, it's 12. Why 12? The original value was 12.5, but it is printed 12. This is called the data loss. Okay, because the integer data type does not accept the value with the dot, means it does not it accept the plain value. It accepts the whole numbers. It does not accept the precision values, the value which is which the value with the decimal point. It does not accept that. That's why the 5 was eliminated and only 12 was stored in the variable I of integer data type. Okay, so while converting data types, you must remember these scenarios. You must understand there can be loss of values, there can be loss of precisions and all that. You must understand these things while coding. Okay, let's switch back to the slides. Here, signed and unsend. So actually, the predefined data types in C# are either signed data types or unsigned data types. Then what is the difference? The only difference between the signed and unsigned data type is the signed data type can store both negative and positive values, but the unsigned data type stores only positive values. Let's understand this from this table. So here is the data type, its description and the range. S byte is the data type, which is a 8-bit signed integer, and it can store the value from -128 to +127. Okay. Short is also signed data type, which is a 16-bit. It can store the values from -32768 to the +32767. Similarly, int, which is a 32-bit signed integer, can store this much of values, and long, which is a 64, can store the tremendous value. Similarly, in case of unsigned data types, here byte is one of the unsigned data types, which is a 8-bit unsigned, and see the difference. It can store only positive value, which start from 0. Okay, it can store from 0 to 255. Similarly, U short, which is a 16-bit, it can store from 0 to 65,535. Similar to U int, which is a 32-bit, can store this much of value, and the U long, which is a 64-bit unsigned integer, can store this much of values. The other data types like char, which is a 16-bit single Unicode character data type, can store any value between this range. Float, which is a 32-bit single precision floating point data type, can store value between these. Like similarly, like double, which is a 64-bit double precision floating point data type, can store this much of values, and that is decimal, which is the highest, like 128-bit data type, can store this much of values. Okay, so this is the difference between unsigned and unsigned. So in such scenarios where you want to assign the negative value to some variable, so you must use the signed data type over there, and in such cases where you want to assign the positive value, you must use the unsigned data types over there. Okay, so here you must have noticed that the range, the minimum and the maximum value that we can assign to the variable of specific data type, but remembering these values is a little bit difficult. It's a bit difficult but you can remain, for example, you can remain 0 to 255 byte. You can remember that. You can remember u short 0 to 65535, but you can't remember like u int and u long. It's very difficult to remember. So don't worry, we have an alternative to that. So there are the two properties like mean value and max value. Each data type has these properties which denotes what is the minimum value and the maximum value we can store to the variable of certain data type. Let's see this in action. So for example, here I have the data type byte. Byte b equals, so here I don't know what is the maximum value I can store in this variable. So that is, you just want to assign the first scenario. Let's take the first scenario. You want to assign the maximum value the byte variable can store. Okay, so let's see, you can directly store the maximum value byte dot max value. So this value represents the largest possible value of the system dot byte. Okay, now let's print it. Max value of byte b. Let's run the application to see what is the maximum value that we can assign to the variable byte b of data type byte c. It is a 255. Okay, we can assign maximum 255 value to this variable. Similarly, let's see what is the minimum value. Byte m equals byte dot min value. Let's copy this statement, control C, place over here, change it to minimum and change it to m. Press Ctrl F5 to run the application. See, the minimum value is 0 and the maximum value that can be assigned to the data type is a 255. We can experiment the same with the integer, which is a larger data type value, because you can remember the byte u short but you can't remember the integer. So let's see, print here the int equals int dot max value and int m equals int dot main value. Let's change it here ints for better understanding, to avoid confusion. Let's run the application using Ctrl F5. It's taking time, I don't know how. Oh sorry, where is it? Oops, what happened? It's taking so much time. Okay, I think it's taking so much time to assign. Let's directly print here. Okay, let's directly print int dot min value, int dot max value. Okay, so let's remove the, I think it is taking time to assign those values. Let's directly print the minimum and maximum values of integer data type. See, the min value of integer is this and max value is this. You can also see here the sign data type integer accepts the value in negative to the positive. Okay, it can accept value between this range. You can experiment the same with the other data types like byte, short, u short, long, u long, etc. You can experiment with this and find out what is the minimum and maximum value the specific data type can store. Let's switch back to the slides. The last topic is memory. See how the memory is allocated to the data types. Have you ever imagined? Let's see, let's understand. Means there's a question how the compiler allocates memory specific area to the specific data type. Okay, so to find out how much memory is allocated, we have one operator which is called size of. This size of operator tells us that the memory occupied by the data type in bytes. Okay, it returns the value in bytes. Let's see it practically. Okay, so here I will directly print on the console that the integer allocates specific area, specific bytes into the memory. The bytes occupied by int are, say, size of, here size of comes int. Okay, let's run it, pressing Ctrl F5. It's very simple. There's only one operator, size of. See, the bytes occupied by int are 4. The compiler allocates 4 bytes to the int, to the variable of int data type, and the value is stored in that 4 bytes only. Okay, let's say size of another data type, which say byte. Let's say byte. Press Ctrl F5. See how much size is allocated to the byte variable in bytes. Only one byte means 8 bits. Okay, so actually if you have seen here, we have mentioned that byte is a 8-bit unsigned integer, 16-bit. So 1 byte equals 8 bits. Okay, so if you want to get the value in bytes, just simply multiply by 8. Press Ctrl F5. 8. So byte is a 8-bit integer variable, 8-bit unsigned integer variable. So you can experiment with the other data types to get the value, to get the memory allocated to the or certain data type by the compiler. Okay, experiment with the different data types to increase your knowledge, and this helps us in declaring the variable or specific data types and storing value. Means if you want to store only up to the 30,000 or 20,000 value to the variable, then you don't have to use the integer variable, which stores a very large amount of value. You can use a short variable simply. So instead of using integer, you can use short variable. This will help you in improving performance of the application. So always remember this: the range of values we can assign to the variable of specific data type, and based on your situation, based on your uh, what kind of value, based on your program application, that means you are going to store that much of value into the variable. So this will help you in increasing your performance of your application. So that is it for the day. If you like this video, if you like this lecture, please like it. If you have any doubt, please comment on this video. I will resolve all your doubts, and please share this video among your friends, so let them know also what is the data type and how much means the range of values we can store in the particular data types. Let them know how we can improve the performance of application by by declaring appropriate data type for the value. And also, if you haven't subscribed to this channel, please subscribe it. And thank you for the day. Bye bye.